Hi everyone, this is Maverick Pua, the chemistry guru. Now in this week's video, we want to go through a question involving intermolecular forces comparing the boiling points of halogenoethane. So let's take a look at this question. The table shows the boiling point of some halogenoalkanes. So we have three compounds. This is a chloroethane, bromoethane, and iodoethane. And the boiling point are given here. You will notice the boiling point increases when you move from chloro compound to bromo compound to iodo compound. Which of the following correctly explains the difference in the boiling point? Statement number 1, the electronegativity difference between the halogen and carbon increases from CCl to Ci bond. Statement number 2, the strength of permanent dipole attraction increases from CCl to Ci bond. Statement number 3, the strength of instantaneous induced dipole attraction increases from CH3CH2Cl to CH3CH2I. Finally, statement 4, the bond energy of CX bond decreases from CCl to Ci bond. Then later we want to decide which of these permutation will be the correct answer. Of course, the topic tested in this question will be under intermolecular forces, and if we look at the compounds given and the boiling point trend, we actually will be able to determine the dominant intermolecular force for this set of compounds. So if we take a look at the boiling point, you notice when you go down the group from chloro to bromo to iodo compound, there is an increase in the boiling point. So this means that the boiling point for my halogenoethane is actually directly proportional to the molar mass and directly proportional to the electron cloud size. When you go down the group involving chlorine to bromine to iodine, the electron cloud size increases, and therefore the electron cloud size for chloroethane, bromoethane, and iodoethane will also increase. And if you think about all the intermolecular forces that we have, which one will the intermolecular force be directly proportional to the electron cloud size? Is actually my instantaneous dipole-induced dipole interaction. And actually, based on this information, we already know the dominant intermolecular force should be ID attraction. Some of us will call this van der Waals forces or dispersion forces, but for this video, I'll just refer to this as ID attraction or instantaneous dipole-induced dipole attraction. So let's take a look at each of these statements and we see which one of them are correct and relevant to comparing the boiling point for these three compounds. So statement number 1, the electronegativity difference between halogen and carbon increases from CCl to Ci bond. So is that statement true or not? Now, chlorine is more electronegative than iodine, and therefore if I consider CCl bond versus Ci bond, CCl bond actually will have a bigger difference in electronegativity than Ci bond. The difference in electronegativity for Ci bond is actually smaller. Involving CCl bond, difference in electronegativity is actually larger. This statement is actually not true in the first place because the electronegativity difference should decrease when you go down the group instead of increase. Statement number 1 is not true, and therefore statement number 1 is not the answer that we want. Now, how about statement number 2? Statement number 2, the strength of permanent dipole attraction increases from CCl to Ci bond. This is actually related to part 1. Because once we have determined that CCl bond, the difference in electronegativity is actually larger, then the consequence will be my CCl bond will be more polar than Ci bond. And if it is more polar, it should have a stronger permanent dipole attraction. And we will expect CCl bond will have a stronger permanent dipole attraction. Ci bond should have weaker PD attraction. So again, this statement which says that the strength of PD attraction increases from CCl to Ci bond is not true because the PD attraction should decrease in terms of strength instead. So statement number 2 is not my answer. How about number 3? Now, statement number 3, the strength of instantaneous dipole-induced dipole attraction increases from CH3CH2Cl, which is my chloroethane, to CH3CH2I, iodoethane. Now, this statement makes sense because we've talked about it previously. We understand that the boiling point trend is related to electron cloud size. So therefore, the dominant IMF should be ID attraction. And to explain ID attraction and how would the increase in electron cloud size affect ID attraction and the boiling point, the explanation is here. So from chloroethane to iodoethane, we'll have a bigger and more polarizable electron cloud. and this means that my instantaneous dipole-induced dipole attraction will be stronger, and I'll need more energy required to overcome the attraction between my molecules, and this will mean that the boiling point increases and the boiling point is higher. So statement number 3 is consistent with the data, and it is explaining the factors affecting ID attraction. So statement 3 is correct, and this will be part of my answer. Finally, statement number 4, the bond energy of CX bond decreases from CCl bond to Ci bond. Now we can actually pick up this information from the data booklet. That statement is actually true. Bond energy for CCl bond to CBr bond to Ci bond, actually it decreases. Now the statement is true, but it doesn't mean that it is relevant to answering this question, because for this question we are comparing boiling point, which is a physical property, so therefore we should be focusing on intermolecular forces and factors affecting physical property. The strength of my CX bond actually affects the reactivity, that means the chemical reaction and how reactive your halogenoalkanes are, and it is not affecting physical properties like boiling point and solubility in organic solvent or solubility in water. So for this statement, even though the statement is true, but it is not relevant to explaining the boiling point of my halogenoethane, so therefore statement 4 is not part of my answer. So finally, we have already gone through the 4 statements, and we can answer this question now. Which of the following correctly explains the difference in the boiling point? Statement number 1 and 2, they are totally not true. Statement number 3 will be part of the answer. Statement number 4 is correct, but it's not relevant to answering this question. So therefore, the answer to this question will be option C, only statement 3 is correct. Alright, so that is the discussion involving this question targeting intermolecular forces. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.